Hello, class. How are you doing? Hope you're enjoying your day back from break. Today we're going to start graphing systems of linear equations. Now, when I say linear equations, you should all think in your mind straight lines. Linear line. So we're thinking straight lines right here. Well, you'll see a couple steps. And the step 1 says write each equation in a form that's easy to graph. We spent a lot of time graphing straight lines, but now instead of graphing one, step 2 says graph equations on the same graph. So let's start off by looking at the first equation, x plus y equals -2. We learned a couple different ways of graphing. The one I'm going to use right now is graphing using intercepts. If I cover up my y's, I see that x equals -2. That means that my x-intercept is going to be right here at -2. Well, if I do the same thing and cover up my x's, I get that y equals -2. Meaning my y-intercept is going to be down here at -2. Well, we said that all I need is 2 points to make a line. So if I connect the dots, that blue line is going to be the line for the equation x plus y equals -2. Well, now let's move on to the second equation. It says y equals 2x plus 1. That means I start my graph at a y-intercept of +1, and my slope is 2, meaning I rise 2, run 1, rise 2, run 1. If I connect those dots with a line, that's going to be the line that I get, that red line. So step 1, write each equation in a form that's easy to graph. I did that. Step 2, graph equations on the same graph. I did that. Now step 3 says estimate the point of intersection. Well, if I look at those two lines, and they're kind of thick, but if I just look at those lines and I think, where does it look like these lines cross each other? Well, right here at -1, -1, it looks like they cross. Now, I'm not going to trick you and give you some crazy decimal intersections. We're going to have nice integer or maybe sometimes nice fractions for my intersection. So if I want to check that -1, -1, that point is the point of intersection, what I'm going to do is choose one of my equations. So let's choose the first one. I'm going to put -1 in for x and -1 in for y. Notice I use my parentheses, and that should equal -2. Well, -1 plus -1, that does in fact equal -2. Does -2 equal -2? Yep. So I know for certain that -1, -1 is the solution to my system, meaning that's the point that they cross. Well, let's move on to example. Example 2 says y equals -x plus 4 and 3x plus y equals 4. Well, my first equation's already in a really nice way for me to graph it. It's in slope-intercept form, so my slope is -1 and my y-intercept is 4. So I come over to my y-axis, do a dot at 4, and my slope is down 1 over 1, down 1 over 1, which is going to give me that big red line. Well, equation 2 says 3x plus y equals 4. Well, I don't want to solve using intercepts because I'm going to get a fraction. So if I put this into slope-intercept form by subtracting 3x on both sides, I get y equals negative 3x plus 4. So I come up to positive 4. I do a dot. Now I go down 3 over 1, down 3 over 1. And if I connect those with my blue line, that's the line I'm going to get. So this is my system. These are two equations. Now my solution, it looks like, is right here at 0, 4. Well, I want to check that because I don't believe it quite yet. I want to make sure that's true. So I'm going to use my first equation to check it. You can pick either one. And I'm going to put 4 in for y equals negative 0 in for x plus 4. Well, what's negative 0? That's just 0. So I'm left with 4 equals 4. Is that true? Yep. So I know without a shadow of a doubt that this is the solution to my system. Now over here we see a big question, and it says how many solutions are there? If I look at my two lines, how many times do they cross? Well, they only cross once, so there's one solution. Moving on to number 3. I'm going to choose a different color this time. You know me and my colors. So my first equation says x plus y equals 3. Well, I could either do this by intercepts or putting it in slope-intercept form. If I stick to my intercepts, I cover up my y's, and I see that x equals 3. To find my y-intercept, I cover up my x's, and I get that y equals positive 3. So to plot my intercepts, I come over to my graph. I do a dot where x is positive 3 and a dot where y is positive 3. You need 2 dots to make a line. Bam! I got my yellow line. Now for my green line, my second equation, I don't want to solve using intercepts. I want to put this in slope-intercept form. So if I add 2x to both sides, I get that y equals 2x minus 6. So I come down to negative 6. It's the bottom of your graph. I go up 2 over 1, up 2 over 1. Connect those with a green line. Now my solution, or where my lines cross, looks to be right here at 3, 0. If I want to check that, let's use blue. Let's use my first equation, and I get that x, or 3, plus y, which is 0, equals 3. Well, does 3 equal 3? Yep. So that is the solution to that system. Let's try one more. I let you go on your own. And this one's going to be a life application problem. So this is a word problem. And it says, suppose you are testing 2 fertilizers on kudzu plants A and B. So I have 2 kudzu plants. Kudzu is a big green plant that covers everything in Georgia, where I'm from. And it says plant A is 6 centimeters tall and growing at a rate of 4 centimeters a day. Well, we said that where I start is going to be my y-intercept. And all slope is my rate of change. Well, I'm changing at a rate of 4 centimeters a day. So I start or I begin at 6, and I'm changing at a rate of 4 centimeters every 1 day. So if I had to write an equation for plant A, I'd have y equals, well, my slope is 4, or 4 over 1, times x, plus where I begin, which is at 6. Well, plant B starts off at 10 centimeters tall. So B begins at 10, and its slope is 2 over 1, or 2 centimeters a day. So plant B, I'd have y equals 2 over 1 times x plus 10. So if I graph these, 1, 2, 3, 4, 5, 6, 7, 8. So there's my little graph. Yours is probably a whole lot neater, but you're not using your finger, haha. So if I begin at 6 and I go up 1, 2, 3, 4, 5, 6, that's where I begin for plant A. Well, my slope is 4 over 1, so I go up 1, 2, 3, 4 over 1. And I can keep making points, and I go up 1, 2, 3, 4 over 1. So I'm going to get some line. It's not that pretty, but we're going to learn how to do this on the calculator too. So they'll make really pretty graphs. So plant B, go up to 10, and that's where I begin. Well, plant B says that I go up 2 over 1, up 2 over 1. So it looks like they have a cross right here. And if I count, it looks like the solution is at 2, 14. That's where it looks like they cross. Well, to be 100% certain, get out your calculator.